Okay, I have just uploaded the slide for this week. You can go to the e-learning for download the slide. Okay, I think we can start our lesson today. Okay, let me see. Okay. Okay, and today we go to another filter algorithms named morphological image processing. And this filter is applied on just a binary image. Yeah, so we go to the first one, and the first one is called erosions or eros. Yeah, okay. And what is the function of this erosion algorithm? Here example, we have the original image like this. Okay, and we want to count the how many circle in this image, right? But after we do the rest hole, and we have the very beautiful image like this. But here you can see that each circle here, they still connect to each other by small amount of pixel here, So because they still connected, so we cannot apply the algorithm to count the circle here, the number of circle here. So we have to apply some filter algorithm to eliminate the connections here, small connection here. All right, small connection here. So we will apply the erosion algorithm. So after you apply the erosion algorithm, you will have this image. Okay. So how can it do that? Okay. The first is for the filter, right? In the previous lesson, if you apply the filter, you have to define the kernel, right? You have to define the kernel for filter. And in the morphological filter, they also use the kernel. They also use the kernel. And in the erosion or eros, they define the kernel like this. And here example, if you define the kernel like a square like this with 111 inside like this, you can say you define a box. And if you define like something like this 111 and 111 here, right, it's like the cross, right? But if you zoom bigger here, and it's like the this or the circle. Okay, the circle. Okay, so the size of the kernel here is also 3 by 3, right? And 5 by 5, right? Okay, and 7 by 7, right? Do not use the kernel 2 by 2 or 4 by 4, because it will make the calculation more difficult. It still can be used, but it will more difficult. And in the kernel, you also have to decide the entry point here. Yeah, and the entry point can be everywhere on in the kernel. Okay, so example, the kernel can be this position, yeah, any position. Okay, so the first thing to do the morphological filter is we have to define the kernel. Okay, and the next one is we will apply the erosions filter. And what is it? So the erosion is followed by this equation. So this is the function of the erosion here, and you can see it's a little complicated equation. Okay, so so let's see in the real example, right? How can it perform? Okay, so let's see, and we can summarize the erosion equation like this. We will define the kernel, right? And the kernel will include 1 or 0, okay? And it will serve inside the image, right? Inside the image. So if this kernel or the number of one position, it similar to the image, so the result will become 1. If just one position here is different with the image, it will give the result 0. So let's have a look at the performance. Okay, here, let's see. So example, I have the image like this. Okay, and this is the kernel. Okay, and then I will serve on this image. Okay, at the first position, so what is the result? 0. Why? Because at least, as I say, at least one position, if it's different, it will become 0 here. So this position, they will give the result 0. And how about the next one? Is it 0? All of 3 are different, right? So 0. And the next one is still, the result is still 0. Why? Because I have different, right? Different. So, and how about this one? 2 are the same, right? But the test is different, right? So the result is still 0. Okay, the result is still 0. And the next one is 1. Why? Because 1 and 1 is 1. Okay, yeah. And the next one is 0, right? Because it's different, right? And this is 0, right? 0, right? And one question is how about this position? Okay, easy, just betting, right? Just betting, and then you can have the result here. Right? So from here, what can we make the conclusion on the result here? What is the comment on the result here? Here you can see, example, you this one is the image we want to recognize. And by using the erosion, this one is eliminate, become 0. All here becomes 0, and this one becomes 0. This one becomes 0. This one 0, and this one 0, and this one 0. Okay. So the result here is just, you can see, just still 1 here, right? Still 1 here. Okay. So the erosion in Vietnamese we call phép co. So that means we will eliminates the pixel. That is not necessary. Okay, so let's see another example. Example here. This is the kernel. The red one is the kernel, and this is our image, right? And then the kernel will serve on the image, and then let's see the result of the performance. Okay, so let's see. Okay, let's see. Because they are still different, right? So the result give you 0 here, right? 0. And here is still different, right? So give you 0. 0, 0, and then 1, right? Exactly, right? Similar. Okay, so this is the result, right? If it's continuing surfing, right, it still give you 0 here, right? So this is the result. This is the result, right? So here you can see that the result is how to say is scale, right? Is scale a number, right? Scale number. So this is the function of the erodes. Function of the erodes. So let's see another example for clearer. Okay, here. Let's see the. Okay, let's see this example, erosion, right? Erosion, right? And this is the kernel. This is the kernel, and this is the definition of erosion. You can see here, very simple sentence here. Okay, and this is the kernel, and then the kernel with the origin or the entry point is similar. The origin here is the left one. So let's see the result of the erosion. And please pay attention here. This symbol is the erosion. Okay, the symbol here. In this morphological, you have to remember the symbol very carefully because you have a lot of symbol. So the symbol here is erosion. Okay. Okay, let's see. The surf here, right, is 0, right? So on this row is the all are 0, right? And here, let's first. Okay, so this is the erosion algorithm. So do you have any questions on this algorithm? Okay, no, right? Okay, so let's see the example for you, the exercise example for you. Okay. Where is it? Wait a moment. Okay, where is it? Ah, here. Yeah, here. Okay. Okay, here. Okay, example here. I give you this picture and this kernel, and on this kernel, I this is the shape of the kernel, and the anchor point here is on the first position here, as a position 0 here. Okay, so let's perform the erosion algorithm by hand. Okay, by hand. So we will go right. I will do the example for you, and I hope that you still see here, right? Okay, we will use this one, right? We serve here, right? Oh, okay, yeah. Okay, we serve here, right? So the result is 0, right? The result is 0, right? Result is 0, and still here is 0, right? So that means on the first row is O0, right? OR0, okay? OR0. How about the second? How about the second one? At this position, at this position, at this position, okay? What is the result? What is the result? 0, okay. How about this one?
E1.
E1, okay, right? E1, okay. E1, okay. So how about the next one? OI0, right? OI0, because there is no 1, 1, 1 similar, right? No 1, 1, 1, right? Similar, right? So the second row, on the second row, right? So on the second row, this is the result here is 1, right? The result here is 1, okay. How about the next one? This position is still 0, right? It's still 0. How about this position? What is the result?
Only 0.
0?
Yeah.
Why?
It still have different from the first.
On the first position? Right?
Yes.
Okay, let me say again. In the erosion, they just consider the number 1. They do not consider the number 0. Okay. As I said before, right? As I said before, in the erosion, the number 1 is similar. They just consider. Okay. So here you can see. Here you can see the number 1 is similar, right? The position is similar, right? It's 1 here, and 1 here, right? So the result here is 1. Result here is 1. Sorry, 1, right? And here is 1. Yeah. How about the next one? Is 0, right? Still 0, right? 0, 0, 0. How about this one?
It's 0, 1.
Right? So, and then 1, right? 1,
Yes.
right? Yeah. So the result is this one, just 1, 1, 1 here. Okay. So here you can see the result do by hand is here, 1, 1, 1. Okay. And then we will use the erosion function of the OpenCV to check. And later I will explain to you the function. And this is the function of the here. This is the function of the OpenCV here. OpenCV. It's very simple. Very simple. Just give the source, right, and the output, right, a destination image, right, and you provide the kernel, provide the kernel here, and the kernel is I already explained to you how to define the kernel, right, on in the previous lesson, right. In this slide, I will give you another definition of the defined kernel, more the use the function of the OpenCV. Okay, so later I will explain more clearly about this. So now go to the slide. Okay, so this is the erosion algorithm, and okay, and the remaining is just the, and this one is for manual programming. We don't use the OpenCV function, but this one I will skip because it's a little difficult for you. Okay, so here the next one is another algorithm. We call this a dilation. So it's the how to say different with erosion. How can we say? The dilation functions. The dilate function is this one. Here, example, we want to just recognize the object here, right? The object here, so or the black pixel here, right? The black pixel here, right? So to do the rational, right? First, we make the histogram of the image, right? And then from the histogram, we see that okay, we can do the histogram, the t value at this one, right? At this point, and then we apply the rational. Okay, and then we apply the rational on the image like this. And one problem here is, okay, we still have the pixel, white pixel inside the red, the black pixel. Why? Because here you can see, right, on the boundary of the circle, right? They are still white pixel, right? White pixel. So when you do the rational, you will have this situation, right? You will meet this situation. So how to eliminate this situation? We can apply the dilation algorithm. So we can apply it, right? The dilation. So the dilation is function is followed by this equation. Okay, well, very another equation. So the symbol of the dilation is a little different with the erosion, right? The erosion is circle and a minus inside, right? But dilation is 0 and plus, right? Plus. So what is the dilation? Okay, so let's see the example. I will give you the example first. Okay, here. Example on the input image and the structuring element like this. Okay, and the dilation is briefly speaking, we can say that if the kernel just one element similar to the image, just one, okay, just one element similar to the image, the result will give you one. So this is the dilation. So it's some kind like the reversion of the erosion, right? Ngược với erosion. Okay. Okay. So let's see the performance. Here is the result is one, right? Right? Because this is still similar, right? But here the result is 0, right? Here is different. But okay, similar. So the result is 1. Here is 1. Here is 1. Here is 1, still 1, right? Here is still 1 because similar, right? Here is still 1, okay? And this one example we betting, right? If we betting this, it is still 1, right? So from this result, what can we say? What can we say? Right? We can say that it will fill the gap. Here, example, example, the original image is this one, right? So they will make this one become 1, right? And then make this one become 1, right? This one become 1, right? Right. So just one remaining is 0, right? Just one remaining is 0. Okay. So if you dilate one more time, the second time, so this one will become 1, right? Will become 1, right? Yeah. So this is the dilation. So I want to say that erosion and dilation, you can do more than one iteration. Example 2, 3, 4, 5, right? But in the example or in the exercise, please just do one iteration. Just do one iteration because we will make the same result and can then I can check your result. Okay, so this is the dilation algorithm. Okay, and let's see more detail about the algorithm. Example here. We can see the dilations here. Okay, just one pixel similar, it will give you the result of 1, right? The anchor point is at the center. Okay. Okay, so let's see the result, right? If it's serve more and it's the 111 here, right? The white color here, right? So what can we say here? It will fill the hole here, right? It will fill the hole here, right? So it's some kind like the very important algorithm in the image processing. Okay, let's discuss more about this image. Example in the at the first time. Example here, I see. Okay, the first thing is what is the requirement to fill the gap here? What is the requirement? The size of the kernel, right, must be bigger than the hole, right? Okay, so if it's bigger, it will fill the hole, right? Fill the hole. Okay, and one more is now example at the initial image. We have this one. Okay, and on this image, we have some noise. Some noise, right? Some noise like this, right? Like this. Okay, so how to eliminate the noise here and still have the result So the first is dilate, right? We dilate it, right? So after we dilate, right, the noise will be bigger, right? The delay, it will be bigger, right? bigger. But after that, we do the erosion, right? So if we choose the erode kernel correctly, right, we can eliminate this one, right? Eliminate, right? So you will have the very, I'll say, very beautiful image, right? And this case already happened. If some of you go back home and then already pre-programming the exercise example, recognize the 200, the number 200 on the maybe previous lesson, right? And you will see that despite you already recognize the 200, but it still have small noise around below, right? And then to eliminate this, you will apply this algorithm to recognize a very beautiful 200 number, the number 200. Okay, so this is the remark of the result of the dilation. Okay, so but one thing you have to pay attention here. Okay, let's go to the more detail. Okay, yeah, dilation as a origin. Okay, you have to pay attention here, right? The arrows, you don't need to flip the kernel, but dilation, you have to flip the kernel. You have to flip the kernel first, and then you apply the dilation. Okay, so let's see the example here. So in this example, they give you this kernel. So if you want to apply the dilation algorithm, the first thing is you have to flip the kernel, right? And then flip the kernel, the origin is go to the right hand side, right? Go to the right hand side. And then you serve the B head on the image. Let's see. Yeah, the origin or entry point on the right hand side, right? Okay, so this is the result, okay, of the dilation. So do you have any questions on this? Okay, you don't have any question, right? Okay, so let's go to the next one. Okay, and as I said, the dilation algorithm will make the pixel how to say thicker. We can say that thicker, right? So example, you have the initial image like this, right? It's some kind like the blur, right? Very blur, and you apply the dilation with the kernel, either this like this, right? The circle like this, and you will have the result like this, right? We have the result like this, and it's easier for test recognition. Okay, and this is the example of the dilation, right? And then this is the result. Okay, So please go back and then do it by yourself. Okay. And in the dilation and erosion, we have one function, very important. Okay, example here is the erosion, okay. And as I said before, in the OpenCV, they will give you another function to define the kernel. We call this the gas structuring element. Okay, and it is the shape here, and the shape here, and you can use this formula to choose, right? Just type CV, right, and then dot, right, and then you will have the list here, and then you can choose, right, and the size of the kernel, right, and the entry point, right, the entry point here. Okay, and let's go to the example, right? Let's go to the example here, right? Yeah, let's see. Okay, this is the definition of the image, right? Okay, this is the source image, right? And then I define the kernel. Right? And then I define the kernel here, right? And then this one is I myself define the kernel. I don't want to use the OpenCV function, right? So I will give the kernel data here, right? And then I will give the input here, right? Input here. I have to define it at the matrix, and then I apply here, and then I give the entry point here, right? And then you will have the result here, and this one is the result here. And here you can see that the result is identical with the manually, right? Here you have a 255 is kind the you can ignore it, no problem here. The OpenCV error, so you can ignore it, don't worry about it. And this one is identical with the manual. Okay, and the example of using the gas structuring element is this one. Okay, here, this one. Okay, this one. Here you can see I use the OpenCV library to define the structuring element or the kernel here, right? And the kernel here is I use the arrows for the arrows here, right? And the size of the kernel is 6 here, so the size here is 13 multiplied 13. Okay, right? And the entry point is 6. Okay, 6. Okay, so here is the function arrows, right? And how and what is the function of dilate? Just change the name arrow here to dilate. So the remaining is identical or similar. Okay, so this is the result example. This is the image, right? And then after apply the erosion, and I have this one, right? And the circle now is separate to each other, and then I can count it how many circle here. And for the dilate algorithm, right, I just change this one to dilate, right? Change arrow to dilate, and then here you can see I will fill the gap, small gap here. And okay, so one question here. How do I know the size of the kernel, right? It have many size, right? 3, 3, 5, 5, right? So why I know this is 13 by 13, right? Okay, so this number is not fixed. You can tune. I tune by myself. So this result is obtained by experiment. So just tuning, trial and error, 11, 11, 9, and 9, and then see the result. Okay. Okay, so do you have any questions? Okay, so we go to the next one. Okay, so this is just the exercise, right? You will have the exercise. Okay, and next one is we will go to the opening algorithm. Opening. So the opening here is, this is the symbol, the opening. This is just the circle, opening. And what is it? You can see here. So the opening is very easy. Arrows with dilate, and then arrows with kernel. Arrows with kernel, and then dilate again with this kernel, with that kernel. Oh, arrows and then dilate with similar kernel. So what is the function of the opening? Eliminate protrusion, break the next, smooth contour. So let's see the result. Example, I have the picture like this, and I apply the erosion, and this is the result, the erosion, and the same picture and same kernel. I apply the opening, and this is the result of the opening. So let's see what is the difference. Okay, what is the function of the opening? First one is eliminate protrusion. Protrusion is this one and this one. Protrusion. Okay, so we can eliminate this one. So in this picture, you can see that already deleted, right? Already delete protrusion, right? Break the neck. This one is, we call this is the neck, right? The neck. So this one also delete the neck, okay? And make the smooth contour. So here you can see that we have the fillet here, right? The fillet here, right? The fillet. So the contour is smoother. Okay. So what is the difference between this one and this one? Here you can see that the shape of this one, the shape is more similar than this one, right? The result shape is kind of more similar, right? More similar to the original image. So this is the function, the different function of erosion and opening. Okay, so in the conclusion, what is the opening? Arrows. First is arrows, and then opening we do more, right? Dilate with the same. So we have the function opening. Okay. So here example, another example. Example here we apply the opening function with 3 by 3 square. So what is the result? Is the result here, right? So what can it do? Eliminate protrusion, right? Eliminate protrusion, right? Eliminate protrusion, right? Eliminate protrusion, right? Okay. And then the shape here you can see is still similar, right? Still similar. Okay. Okay. So here, and one application of opening is this one. Very, very interesting. Here example, I give you this picture, right? and there are a lot of circle and rectangular, right? So example, I want you to just display circle on this image. So how can we do this? So we will apply the opening algorithm with the kernel in this or circle with the diameter is 11 pixel. So after this, right? Example, because we use the opening, right? So first we do the arrows, right? Example, the circle is here, right? The circle. So if because the arrows, right, is not identical, right? So it will eliminate, right? It will eliminate, right? Eliminate. So after we serve on the image, right, we have the result here, right? So the result here is just the circle, okay? Just the circle. Okay, and the question is, now I just want to display the rectangle. Oh, so how can I display? So you have to define the kernel. So example, this one. Example, I have this picture, right? I have this picture, and a lot of rectangular, right? A horizontal, vertical, and have an angle, right? Have an angle. Example, I want to just display the vertical rectangular. So I apply the element like this. 3 by 9. 3 by 9, is it this one? Right? Sorry, 3 by 9. Is it this one? Sorry. Right, vertical. This is the vertical kernel, and this is the horizontal kernel. So after apply this one, you will have this picture. After apply this one, you will have this picture. And one question is, I want to display this one. How? Okay, easy. Just define the kernel or structuring element have the 45 degree like this, and then you will have this one. You will have this one. Okay, so you can this is also a very simple image recognition, the kind of symbol image recognition. Okay, and here is also example, right? You can apply the structuring element with the circle. Here you can recognize the circle like this, some big circle like this, right here. And another is closing. So previous we have opening, right? Opening, and now we have closing. So what is closing? Closing is the circle but bone inside, right? So what is the algorithm? It reverse of the opening. So in closing, we dilate first and then arrows. In opening, what we do? We arrows and then dilate, right? But in closing, we dilate and then arrows. Okay. So what is the function of closing? It still have 4 here. Okay, let's see. Example, I have again this picture, right? And I will apply the closing algorithm on this image. First, I will do the dilation. I have this one. And after that, I apply closing is this one. I arrows, right? Arrows with P again, right? So here, I have this one, right? This one is closing, right? Closing. So what is the result here? What can we say? What can we say? What can we say? Smooth contour. Yeah, smooth contour, right? Eliminate small holes. This one is similar. Eliminate small hole or fill gap. This is similar. Here you can see this is the small hole. You can eliminate it or fill the gap here, and then it will fill the gap here, right? Fill the gap. Because this hole is too big, so we cannot, right? But if you apply the kernel bigger, I hope that you can fill this gap, right? Smooth contour, right? Smooth contour. Still smooth contour. And another is fuse narrow break, right? What is it? Okay, let's see. It's like eliminate protrusion. Here. Example here is closing, and then we apply the structuring element 3 by 3, right? And here, because just 3 by 3, so we can fill the whole small hole here, right? The big hole we cannot, right? Small hole. And then what can it do? It will fill the gap here, right? Fill the gap. Right? Fill the gap here, right? Fill the gap. Right? Okay. So this is the function, right? Function of the closing. Example, another example here. Example, I give you this image, and then I want to just display the big circle, the bigger circle. So I will apply this 22 here. This is the diameter, right? This is the kernel is the circle. So after that, I have this image. Right? And one question here is now actually I want to display the small one, and I don't want to display the big one. So what should I do?
Reduce the kernel.
Reduce the kernel. Reduce the kernel. No, if you reduce the kernel, reduce the size of the kernel, you cannot fill in here. You cannot dilate. You cannot dilate. Right? So now I want to just display the small one. I don't want to display this one, right? So I apply this one, and then what is it? I use this image minus this image. Is it?
Yes.
Yeah. Right? Yeah. I minus, right? And then I will have the small hole here, right? Yeah. Okay. Yeah. So what I want to say here, you can do the subtraction or plus in this binary image. Okay. So this is another example, and this is the example exercise for you. So let's have a look at the exercise. Okay. Okay, here. Example, I have this image. And then the kernel here. Okay. And in this exercise, I give you a very easy one because I give you the kernel, but it's some kind symmetric, right? Symmetric kernel. So If this is symmetric kernel, you don't need to flip the kernel when you dilate, right? So I said again, please remember, if you do the dilation, you have to flip the kernel, okay? Okay, the first one is we opening by hand, manual. So the first is opening is erode and then dilate, right? So this we erode with this image, right? And this one we erode. So after you serve on this one, right? And which position on this image? Can you tell me which position on this image we erode and still keep one? Which position? This one, right? Let me copy into the pen. It's better, right? Okay. Okay, here. Very easy. Okay, so which position? Example, this is column. We can say this is the row, right? Row and column, right? And then example, if we serve on 111 here, right? Example, this position. Oh, sorry, 3 by 3. Okay, 3 by 3. So example here, right? This one also. Okay. Okay, this one, right? So this one will give you 1, right? Because 1, 1, 1, 1, and 1. So 1, 1, 1, and 1, right? So this position will give you 1, okay? And this position will give you 1, right? Is there another position? This one also, right? Is it? This position. Is it the result give you 1?
Yes.
Yeah, right? Yeah. That's why it's the 0 and different here, but the 1, 1, 1, 1, and 1 here is still similar, right? So it will give you 1. So the result of the arrows is 1 here, 1 here, and 1 here, right? 3 position. Okay. So where is my mouse? Okay. And this is the result of the erosion. Erosion, right? Erosion. And then we do the dilation, right? The dilation with the same kernel. And then this is the result of the dilation. Okay. So we will check it with the OpenCV library. And in the OpenCV library, we have the function called morphology. Morphology here. Morphology. Here. Morphology. Okay. So in this function have another many parameter. Okay. So right, destination, right? The option here, right? The option here you can choose. Example, you want to do the opening, you can choose the morph open, right? Just use CV dot dot, right? And then you will have the list, and then you can choose which one you want. Which one you want, okay? So this one is you want to choose, right? And this is the kernel you have to define, right? And this is answer point, right? And this is the iteration. So give it default just 1, okay? Just 1. And then this is the border type. So you have to look at the parameter here, and you have to study by yourself what is the meaning border constant, what is maybe this is bedding 0 or duplicate the border or something like that. You have to choose by yourself, right? And this one you choose the default like this, okay? And here this is the demo of the function, very simple like this. everything remaining give default, so don't use anything. And here I define the cross structural element or cross kernel. And then here you can see that when I apply the function morphology, right? Here to do the opening algorithm, we have two methods. One is we do the arrows and then we dilate, right? Or we use directly one function, morphology. And here you can see that the morphology function and after dilation is identical, similar. This one and this one is similar, identical. So this is the function, the opening function, and the closing function is also identical. It's also similar. You can practice by yourself. Okay. And some kind you will have some exercise, something like this. Example, I want you give you this picture, and then I want you to just display the circle, just display the rectangle, or vertical, or horizontal, right? Line, or just the 45-degree lines like this. Okay. So you have to choose the kernel by yourself, and then define the size of the kernel by yourself. Just tuning. Okay. So this is the closing function. Okay. And this is another example. Just use the morphology function, right? Okay. Okay. And then as I said before, you can apply or combine the algorithm to form another algorithm we call boundary extraction, like this. Boundary extraction. What is the function? What is the meaning? We arrows with the kernel, and then we use the original image minus with the arrows with the result, right? We have the result here, right? And then we have the original minus result, and then we will have the boundary extraction, something like this. You arrows with the kernel here, and then this is the result, and then this one a minus, and then you have this one. Okay, let's see the animation for clearer. First we arrows, right? Okay, so this is the method for boundary extraction. Apply the morphological image processing, right? So do you have any question on this one? No, right? Because it's very easy, right? Okay. Okay, and it is a real image. And then you can apply the algorithm, and then you have the boundary like this. And this one is the coding in the OpenCV. Very easy, just erode, right? And then in the OpenCV, they give you the function subtract. So just apply the function, and then you will have the result on this one. And here I try many kernel. Example 5.5, 5.5, and let's see 10.10, 10.10. Yeah, just try. Okay. And another algorithm is we can call this is the hole filling. So what is it? So the hole filling is this function. Wow, you see, now it's some kind of more complicated mathematics, right? So this you remember what is this symbol? You see dilation, right? Dilation, right? Dilation. Okay, this is dilation. So what is the hole filling algorithm? Very straightforward. This is A is the original image. The first one is we do the complement of it. We do the complement. And then we do the iteration here. We do the dilation with the kernel P, right? Example, in the first iteration, we have the x0, the result is x0 equal to x1, right? Erosion B, right? And then intersect AC, right? And then in the iteration 2, what is it? X2 will equal to x1, right? And that's right. Go iteration B, right? And then AC, right? And then the iteration continue, and then we stop when the previous and the next one is similar. Okay, so let's go to the example. Example here. Okay. Example, I give you this one. I give you this one, right? And I want you to fill the hole. So that means this one will become 1, 1, 1, right? Fill the hole, right? Fill the hole, right? So how can it do? We will apply the hole filling algorithm. The first is, as I said, right? As I said, what is it? Do the complement. What is the complement? Bầu. 0 become 1, right? 0 become 1, right? And then after we do the complement, we have this one. Right? This one. And example, we use the structuring element of kernel B here, right? And then x0, what is it? So x0 here is number D here. So x0 here is we have to find by ourselves the point inside, right? Inside the boundary. Okay. I said again, the requirement of the algorithm is that the first point we have to find by ourselves. The point must be inside the boundary. Okay. So the first one is we find example. The first one is inside the boundary. This one is this position, right? This position. And then we will apply the algorithm, right? What is the algorithm? X1 will equal to what? X0, right? Dilate B, right? And intersect AC, right? AC. Okay, so we will use this one to dilate. So when we dilate, what is the result? We serve this one, right, on this image, right? Serve this one. And then example, we have this position, this position, right? this position, right? So what is the result here? What is the result? The result here is 1, right? Is it? Yeah, because this is the structuring element, right? The dilation is just 1, just 1 element similar. It will give the result 1, right? So here, right, 1 element is similar, right? 1 element similar. Okay, so this one will give you the 1 here, right? And then after we surf on the image, right? So this one will give you the 1 here, right? Is it this one? 1? Yeah, this one, right? Right? And this one is 1, right? Right? This one is 1, right? How about this one? This one is 0, right? Because this is the like the cross, right? The cross. Just this one is similar, right? But here is here, right? So this one is 0, right? So after the first, so we will have, what is the result here? 1, 1, 1, and 1 here, right? So, and then we use this one, what is it? To intersect with AC, right? Intersect. So, example here, right? This position here, right? So we have this one is 1 here, right? And let's say 1, 1, 1, and 1. So what is the result? Is it this one? Yeah. Yeah, correct. Right? Correct. Okay. And then the next one is similar. Similar. The next one is similar, right? X2. So what is it? So just apply dilate first, right? The B dilate on this one, right? So what is the result of when B dilate here? So it's the 1, right? And this one is also 1, right? Right? And this one is also, this one is 1? Yeah, because here is similar here, right? So this is 1, right? And this one is also 1, right? And this one is 1, right? Okay. So example, we have this one. We have this one, right? We have this one. And then with this one is 1 here, right? So based on this one, we have 1 here, 1 here, right? And then 1 here, 1 here, right? And then 1 here, right? Right? Yeah. It's also this one is 1, right? 1. So we intersect, right? We intersect this one and this one. What is the result? Just have 1 more here, right? Is it? I just have 1 more, right? This one is 0 and 1 is so delete, right? Delete, right? So it's have 1 here, right? So the x2 is here. Okay, and then the next one we will have this one. The final is xa, and then if you apply more, you cannot have more results. So the final is this one, and here is the result. This one. Right here the result. Okay, so let's see the animations. First one, right? Right. Second, right? Okay. Yeah. So this is the whole filling algorithm. So do you have any questions? Okay, so I already demo for you the algorithm, right? So it's not so difficult. Okay. And here you can see that you can fill the hole inside here. The hole inside here. Okay. Fill the hole inside. And in the our CV, you have some kind like the fluid fill algorithm here, right? Okay. So after that, you have this one. Okay. I think the today I already presented you so many algorithms. So I think that's enough for today. Right. So do you have any question on the content of the lecture note today? Okay. So if you don't have any questions, we can dismiss the class now.
Cảm thế.
Okay, so our class dismissed. Thank you for your attendance today. Yeah.